All right, guys. So far, so good. And I know it's been a trip with this Trig stuff. We've got, I think, one or two more things that we have to talk about with Trig, and then we'll be done with it for a little while. Okay. So there's a light coming. So this next thing we're going to talk about is actually solving for x. We've been doing everything as far as finding out what sine is, finding out cosine is, making triangles, coming with the laws of cosines, the laws of sines, all right, and using all of that to find pieces of triangles. But now let's actually go back to algebra. Remember algebra? Oh yes. How do I solve something like this? Remember algebra? And I'm hoping this is fairly straightforward, right? I subtract 1 from each side on this one, right? Add 1, excuse me, and divide by 2, and I get x is equal to a positive 1/2. Well, that's very similar to what we're going to do here. In solving trig equations, the number one thing that you got to remember is that we're going to pretend that my trig function, whatever it is in the equation, is like a big giant x. Big giant unknown. And I do the same performances of the same things. I add 1 to both sides of the equation. I get 2 sine x is equal to 1. Divide both sides by 2. Sine x is equal to 1/2. And I'm almost done. But we have to remember something. What is it that we have to remember? We have to remember that sine equaling 1/2 happens at 2 different places. Right? Because you think you might be done. Remember sine happens at 2 different places. And if we use our unit circle, we can see that it happens not only at pi over 6, the sine of x equal 1/2, and 5 pi over 6 is also sine of x equals 1/2. It happens twice, and here's a graphical representation. Not only that, but are those the only 2 places that happens? No. And unless the equation specifically restricts your domain, you have to remember that this keeps repeating over and over again every circle or every 2 pi. So your solutions aren't just going to be that x is equal to pi over 6. No, 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 no. You're going to be x is equal to pi over 6 plus 2 pi n. Well, what's n? N is any number, okay, where n is any number 1, 2, 3, ... Any number of circles. It happens every time. But not only does it happen there, but it also happens at 5 pi over 6. So x is equal to 5 pi over 6 plus 2 pi n. Again, that happens over and over and over again. Okay? So unless they specifically say your answers need to look like this. All right? So let's take a look at more examples. So our first one that we're going to take a look at says sine of x equals square root of 2 is equal to negative sine of x. Again, look here though. They restrict our domain, so I don't have to put it over and over and over again. Okay? So let's take a look at this. So, again, so I treat this as where I think to myself, hey self, this right here, pretend it's a big giant x. This right here, pretend it's a big giant negative x. So what do I want to do? Well, I can add a big giant sine x, right? Pretend it's, add a big giant sine x to both sides. Okay? So I'm going to do that. So we're pretending that's in our mind. So I'm going to do that. I'm going to add a big giant sine x. I'm going to add this sine x over here. So if I got sine x plus sine x, well, that's 2 sine x. And I'm going to do a second step because I believe you guys can handle this. I'm also going to subtract the square root of 2 over here. I'm going to subtract the square root of 2 over here too. So I'm going to get this as equal to negative square root of 2. Again, pretending that the sine of x is a big giant x, I divide both sides by 2. I get sine of x is equal to negative square root of 2 over 2. Whew. Great. So now what? Now you have to find where is sine of x equal to square root of 2, negative square root of 2 over 2. And this is where you have to get your, unit circle out, draw the little unit circle, right? You got to remember the acronym of where, we need to find out where sine is negative. So we remember all students take calculus. So in this quadrant, everything is positive. In this one, sine is positive. So I don't care about those two. So over here is where sine is negative. Okay. So then I have to think about, okay, in my reference angle zone, where is sine of x equal to negative square root of 2 over 2? And that happens here at pi over 4. So I want the same reference angle, pi over 4, here in the third and fourth quadrants. So which one is that over here? That's when x is equal to 5 pi over 4. And so that's over here. There's 5 pi over 4. And then this one over here, 7 pi over 4. And here we don't say and, it's or. Okay? Either it's 5 pi over 4 or it's 7 pi over 4. Those are the two places. Okay? Woo! Now you're probably asking, Mister, why can't I just use a calculator? Why can't I just say, inverse sine, right? I want to undo sine and do the inverse sine. Well, your problem is this, is that inverse sine will give you, will give you the 7 pi over 4 number. It will not give you the 5 pi over 4 number. And that's something that you need to be like, oh. Not only that, but the 7 pi over 4 number will be, just decimals. It won't be accurate. Ooh. So you're saying I really have to know the unit circle? Yeah, you need to at least be able to bring out your unit circle, have it sitting there with you. In fact, if you haven't gotten it already, go find a copy of it or find one online and bring it next to you so you can work with me on these problems. Let's go to the next one. Here we go. All right. Solve for x. If x is between 0 and 2 pi, again, it's restricting my domain, so I do not have to write those funkiness as far as all those extra stuff about adding a 2 pi over 2 pi n stuff. Okay. So again, I want to treat tangent of x as a big giant variable that I'm going to solve for. That's my first step. So I'm going to subtract 2 square roots of 3 from both sides. So 2 tangent x is equal to negative 2 square roots of 3. Divide both sides by 2, and I get tangent of x is equal to negative square root of 3. And you probably think, wow, Mister, how unit circle just has sine and cosine. But you got to remember something, guys. Here's what you have to remember. That tangent of theta is made up of, right, sine of theta divided by cosine of theta. And here's a little trick I like to share. Tangent is square root of 3 when sine of theta is equal to square root of 3 over 2. Okay? All the times that, square root of 3 over 2. All right? That's where I got to think about that. Again, I bring out my unit circle. Where is sine of theta going to be equal to square root of 3 over 2? That happens at that reference angle of pi over 3. What does that mean? That means over here, my reference angle, right? Here I am, reference angle. There it is, pi over 3. That's where sine is equal to square root of 3 over 2. Okay? But again, I have to remember, what am I looking for? I'm looking for the negative square root. So I do all students take calculus. Again, where is it negative? Everything's positive here, so I don't care about that. Every tangent's positive here, so I don't care about that. It's at these. So, where's this going to be at? That's at 2 pi over 3. This one's at 5 pi over 3. So tangent is equal to the negative square root of 3 at those two locations. And I go, so x is equal to 2 pi over 3, or x is equal to 5 pi over 3. Use the unit circle. Be able to find it. Okay, start finding patterns if you need to. Take some extra time looking at them. Try to find the patterns. Alright, so now we have another technique, right, that we have to show you about solving these. Same thing though. I still want to treat this as a square root, as a tangent is going to be a big giant variable. So this is like saying x squared minus 3 equals 0. Oh, so what am I going to do? I'm going to keep my variable. And I add 3 to both sides. Is equal to 3. And so what do I got to do? Again, I got to ask myself, how do I undo squaring? I take the square root. So tangent of x is equal to square root of 3. But I can't forget that when I take the square root, okay, it's plus or minus 3, square root of 3. So reality is I have two equations here. All right, my two equations are tangent of x is equal to a square root of 3, and tangent of x is equal to a negative square root of 3. Well, shoot, this problem right here, we just got done solving that one, right? We found out that that happens, okay, of x, not tangent of x, but x is equal to, that x is equal to, that happens when x is equal to 2 pi over 3, or x is equal to 5 pi over 3. And what about for the positive one? Well, again, it's going to be all the ones where sine is equal to square root of 3 over 2, where tangent is positive. So that's in quadrant 1. So that's when x is equal to pi over 3. And then in quadrant 3, when x is equal to 4 pi over 3. And those are my 4 answers. I actually have 4 answers for that one. I could plug in anything into that, and it gets me a correct answer, those 4 answers. Whoa! And that's what's different about trig equations versus regular stuff. X at most was maybe 2 answers at most. Sometimes, you know, most of the times 1, but sometimes 2. Here you can have 2 at least, and it could be 3 or 4, 5. You just have to be thinking about it. Sometimes infinitely many, right? When I have to do that thing, weird thing I had to do at the beginning. So let's see some more. Then you get to this and you go, OMG. This will be, let's see here. We have this one. And maybe one more. We'll see. We'll see how this works. Okay. So when we get to this, it's like, well, what can I do? It's got 2 things in there, tangent and sine. Well, there's a couple of things we can do. Okay, our first tactic that we're going to use is get everything to one side. So I'm going to have here, oops, my first tactic that I'm going to run is I'm going to say, well, let's get everything to one side. So I'm going to subtract the 2 tangent x. So subtract the 2 tangent x from each side. And that equals 0. And then what I can see is that, hey, you know, once I have it here, I can kind of take out a tangent x, right? Okay. Take out that tangent x. I have tangent x. And here I've got sine squared x left over, and I got minus a 2 left over inside of here, and this equals 0. Well, now that I've factored this, it's like when I had factored things with x before. So now I have two things that are being multiplied together that equals 0. So either tan of x equals 0, or sine squared x minus 2 equals 0. It's one of those two things is going to happen. So I set this up and I say, well, I set it up. Tan of x equals 0. And sine squared x minus 2 equals 0. What's kind of cool about this one is I do this over here. I get sine of x is equal to the square root of 2. And hopefully you realize the square root of 2 is greater than 1. Why is that important? Because if you look at your unit circle, sine of x can never be more than 1. So here's a little hint. If you have a trig function, specifically sine and cosine, and you have to realize this, if sine or cosine is equal to something that's more than 1, guess what? On this side of the equation, x has no solutions. Empty set. So now all that's left over is when tangent of x is equal to 0. Well, when does that happen? Again, that happens when, because tangent of x is equal to sine or cosine, is when sine is equal to 0. And sine is equal to 0 when x is equal to 0 or x is equal to pi. Those are my two times. Those are my two answers. Or. Okay. And I'm done.